Okay, this is picking up from where we left off in class. These are just a few absolute value inequalities that you can quickly see are either the empty set or the whole set of real numbers or something else kind of different. So for example, this first one, absolute value of x plus 2 is less than -4, and absolute value is never negative. So it's definitely not going to be less than -4. So this would be the empty set. So there's no need to even fool around with that problem. It's just absolute value is never less than -4. Absolute value of anything is never less than -4. Over here, we've got the absolute value of x plus 2 is greater than or equal to -4, and that's going to be always, no matter what x is, the absolute value of it is always going to be greater than or equal to -4. It will never be less than a negative number. It's always going to be greater than a negative number. So for this one, x would just be a real number. Any real number will work in that inequality. Over here, we have the absolute value of x minus 5 is less than or equal to 0. Well, it's never going to be less than 0, that's for sure, because it's an absolute value, so it's positive. But it could equal 0. So for this one, we would just write x minus 5 equals 0, and we would say x equals 5, because that would be the only value you could put in there that would actually work in this inequality, because the absolute value of 5 minus 5 is less than or equal to 0. It's actually equal to 0, but it is less than or equal to 0. We can say that would be a true statement. So x would be 5. That would be the only possibility for that one. Over here, you have the absolute value of x minus 5 is greater than 0. Now this is a little bit tricky because an absolute value can equal 0. So we don't want x to be 5 here because that wouldn't make this a true statement. So we know that the absolute value of x minus 5 is always greater than or equal to 0 because it's an absolute value. But if we just want it to be greater than 0, then we can only talk about values of x that are not equal to 5. Let me just repeat that. If I put 5 in there for x, then I'm going to get 5 minus 5, absolute value of 5 minus 5 is greater than 0. 0 is greater than 0, and that's not true. Okay, so the only thing that won't work in this particular inequality is x equals 5. So for this solution set, we would have to say all x such that x does not equal 5. But any other value for x is going to make this work because every absolute value is greater than or equal to 0. They're all positive numbers. So every single possibility for x will work. It's just that x minus 5, x equals 5 doesn't work because it makes it equal to 0, and that's not what this particular inequality is talking about. Okay, using a linear inequality in an application of grades. Shanice has test scores of 96, 84, 80, 98, and 88. Her score for online homework is 100, which is weighted as 1 test grade. Shanice still needs to take the final exam, which counts as 2 test grades. What score does she need on the final exam to have an average of at least 90? This is the minimum average to earn an A in the class. So the first thing we're going to do is add up all those test scores. So we've got 96 plus 84 plus 80 plus 98 plus 88. And then she's got this homework grade, which also counts as a test, so we'll add that on. And then she's got her final exam, which counts as 2 test grades. So that's the score we don't know. So we are going to add that twice because it counts as 2 tests. And then we're going to divide by the number of test grades. So 1, 2, 3, 4, 5, 6, 7, 8. So if we divide by 8, that's going to be her average. And she wants to make an A, so she wants her average to be greater than or equal to 90. So now we're just going to solve for x to find out what she needs to make on that final exam. So if we add up all those test grades that we already know, that's 546 plus 2x over 8. We want that to be greater than or equal to 90. We'll have, if we multiply both sides by 8, we'll have 546 plus 2x is greater than or equal to 720. If we subtract 546 on both sides, we're going to have 2x is greater than or equal to 174. And so if we divide both sides by 2, we're going to have x is greater than or equal to 87. So she's got to make an 87 at least on that final exam in order to make an A in the class. Suppose that a machine is calibrated to dispense 8 fluid ounces of orange juice into a plastic bottle with a measurement error of no more than 0.05 fluid ounces. Let X represent the actual amount of orange juice poured into the bottle. Part A, write an absolute value inequality that represents an interval in which to estimate X. When they say a measurement error of no more than 0.05 fluid ounces, what they mean is that you want to make sure in each bottle there is only 8 ounces, maybe 8.05 or maybe 7.95, but that close. So the margin of error means you can have that much more or less than 8 fluid ounces, but no more. No more of a difference. So to say that using an absolute value, what you're going to say is, okay, however much is in the bottle, that's X. That's what it says. If the difference between that and 8, which is what you really want to be in there, you want the difference between those two numbers to be less than or equal to 0.05. So you want the difference in the amount that's in the bottle and 8. You don't want it to be any more of a difference than 0.05. So you're saying either, if X is 8.05, that's okay. If it's 8.04 or 8.02, that's all right. Or if it's, 7.95 or 7.96, that's okay. So whatever X is, if you subtract 8 from it, you want that number, it could be negative or positive, but you want it to be, the absolute value of it, to be less than or equal to 0.05. And in order for that to happen, X minus 8 has to be less than or equal to 0.05, and X minus 8 has to be greater than or equal to negative 0.05, because that's how it works with a less than absolute value problem, because you want it to be less than the positive number, but you don't want it to go too far to the left because you want it to stay close around 0. So it's got to be less than or equal to 0.05, but greater than or equal to negative 0.05. So when you solve for X, that just means that X has to be less than or equal to 8.05, and X has to be greater than or equal to negative 7.95.